Okay, I'm going to just do some practice now of writing half reactions. I just did a video on how to, or what the half reactions are, that we have a reduction and an oxidation and we separate those out. We're just going to do some practice actually doing that. We're going to do a couple simple ones, then we'll do another video with a couple of harder ones, and all of this is leading us towards being able to balance reduction oxidation reactions. So, first thing we're going to do is we're going to identify the oxidation state of all of the elements, looking for the ones that are changing. Number two, we're going to write out the atoms with the changing oxidation state, making sure that they're balanced. And then number three, we're going to determine how many electrons are lost and gained and make sure we balance those, and that will support us in balancing the overall reaction. So here I have copper nitrate, copper 1, I guess there's just one there, I didn't need that one. There we go. And zinc, and we have a single displacement reaction here where zinc is going to take the place of the copper, and the copper is going to be displaced out as a solid. So in these polyatomics here, because the polyatomic doesn't change, I can consider it just as one big polyatomic whose charge is, in this case, -1, and in this case, -2. Or sorry, -1, but there are two of them, and so -2. So copper is an element here at 0. Here it's with a -1, so it's +1. Zinc is a 0 element here, and here it's with a -2, so it's going to be +2. So the copper is going from +1 to 0, and the zinc is going from 0 to +2. So copper +1 is going to copper with no charge, and zinc 0 is going to zinc with a charge of +2. This is our reduction as the oxidation number is being reduced. This is our oxidation because our oxidation number is being increased. So here we want to make sure that our electrons make sense. So if I have something that was +1 and I'm going to make it neutral, the way I do that is by adding 1 electron to it. But we can see the trick here is that charge on either side of this reaction needs to be balanced. So over here I have a charge of 0, which means over here I need a charge of 0 as well. I had +1, so I have to add a -1 to it to make it go back to the 0. Similarly, if I had an object that was at a charge of 0 and I wanted to get it to a charge of +2, I would do that by having it release 2 electrons. Those 2 electrons will allow the charge to balance in the same way, where this charge on this side was 0, and now we're up to +2, -2, and so the charge is balanced on this side as well. So you can look at it as balancing out the actual charge on either side of the reaction, or you can think about it back to grade 9 electrostatics in terms of what you have to do to make an object change its charge. Things become negative by gaining electrons, things become positive by losing electrons, and things that are negative can become neutral by giving away electrons, and things that are positive can become neutral by gaining electrons. Okay. Also, we know that reduction is gaining electrons, and oxidation is losing electrons. Okay, with all that in hand, we can see this reaction, and it's almost good, but we have a problem. The copper is only consuming 1 electron, while the zinc is giving off 2 electrons. We can fix this, or balance this, by multiplying everything in this reaction by 2. So we can say 2 copper plus ions are going to 2 neutral copper ions while taking in 2 electrons. So now we have 2 balanced half reactions. That actually helps us with the overall equation if we want to balance it, because what we can see then is that if I put a 2 on the copper nitrate, a 2 on the copper solid will actually end up with our balanced chemical reaction. Now, that's a little bit of an oversimplification. We're going to have to look at that actual balancing in a lot more detail. Right now, we're just focused on writing out our half reactions and balancing them for the number of electrons. Let's look at another one that should be pretty straightforward. Tin oxide plus carbon is going to go to tin and carbon dioxide. Here, my tin has an oxidation state of +4. I can tell it's multivalent, so I have to check, because my oxygen is 2 minus 2, so that's -4, so the other one has to be +4. Here my carbon is an element, so it's going to be 0. Here it's going to 2 minus 2 is for -4, so the carbon here has to be +4. And here our tin is an element, so that has to be 0. So tin is going from +4 to 0, and carbon is going from 0 to +4. The tin has a reduced oxidation state, so that's the reduction. And the carbon has an increased oxidation state, so that's the oxidation. Now, how do I get something that's +4 and get it back to 0? Well, if it was +4 and I want to neutralize it, I can add 4 electrons to it. Or I can think I have +4, so I need a -4 to get it to 0. Similarly, I have something 0 and I want to get it a charge of +4. How can I do that? Well, I can add 4 electrons in. +4 minus 4 goes to 0. And in this case, we have 4 electrons turning into 4 electrons. And so these half reactions actually match each other just how they are, and we don't have to do anything further beyond this point. So sometimes the electrons will match nicely, or sometimes you're going to have to use normal balancing techniques to figure out how to make sure the number of electrons going and coming is the same. So those are the two half reactions. In my next video, I'm going to look at some trickier stuff, and we'll look at those then.